Lesson 12. Advanced Arduino Programming, Part 1. Contents. The topics covered in this lesson are decimal and binary system, math operators. The task or activity for this lesson includes example problems in the topics learned. Decimal system. A decimal numeral system is the system whose numbers are represented with digits 0 to 9 only. The number is expressed as a base 10 reference system. Examples: 2 base 10, 5 base 10, 10 base 10, 100 base 10. All the numbers are referenced as base 10 as shown. The base is always represented as a subscript. Binary system. A numeral system whose numbers are represented with digits 0 and 1 only. The number is expressed as a base 2 reference system. Examples: 00 base 2, 10 base 2, 10 is not number 10, but equals to number 2 in the base 2 system, 01 base 2, 010 base 2. Decimal to binary conversion. The process of converting a decimal number to binary number is called successive division. Conversion process. Divide the decimal number by 2. The remainder is the least significant bit, LSB, of the binary number. The division is continued until the quotient is 0, then the conversion is complete. The new remainder is the next most significant bit, MSB, of the binary number, in every successive division step. Example 1. Convert decimal number 6, base 10, to a binary number, base 2. 6 is divided by 2 since we are converting it into base 2 system. The remainder is 0, which is the LSB of the binary number. The quotient 3 is the dividend for the next division, and the process continues till the quotient is 0. The final remainder is 1, which is the MSB of the binary. The final answer obtained starts with MSB, including all the digits in between, to LSB being the last digit. So the binary equivalent of the decimal number 6 is 0, 1, 1. Activity. Problem 1. Do it yourself. Convert the decimal number 26 into its binary equivalent. Activity. Solution. So the binary equivalent of the decimal number 26 is 0, 1, 0, 1, 1. Activity. Problem 2. Do it yourself. Convert the decimal number 41 into its binary equivalent. Activity. Solution. So the binary equivalent of the decimal number 41 is 1, 0, 0, 1, 0, 1. Here are a few practice examples. Solutions for practice questions. Binary to decimal conversion. The process of converting a binary number to decimal number is called weighted multiplication. Conversion process. The decimal number will be equal to the sum of each binary digit, starting from the leftmost digit, times their power of 2, which is called the bit weighting factor, where n is the no of digits in the binary number. Example: bit 0 equals 2 power 0 equals 1, bit 1 equals 2 power 1 equals 2, bit 2 equals 2 power 2 equals 4, and so on. Example: convert the decimal number 0110 into its decimal equivalent, where n equals 4. Start from LSB. Bit 1 equals 0, is multiplied by 2 power 0, which gives 0. Similarly, bit 2 with 2 power 1, bit 3 with 2 power 2 and bit 4 with 2 power 3. The resulting numbers, 0, 4, 2 and 0 are added, to give the decimal equivalent number of 0110 as 6 base 10. Activity. Problem 1. Do it yourself. Convert the binary number 1, 0, 0, 1, 0, into its decimal equivalent, where n equals 6. Activity. Solution. The decimal equivalent of the binary number 10010 is 18. Here are a few practice examples. Solutions for practice questions. Summary of the decimal and binary conversion processes. Here, review the process for decimal to binary and binary to decimal. Decimal to binary conversion. This is called successive division. Divide the decimal number by 2. Remainder equals LSB of the binary number. If the quotient equals 0, the conversion is complete. Else repeat step. A using the quotient equals decimal number and new remainder equals next MSB of the binary number. Binary to decimal conversion. This is called weighted multiplication. Multiply each bit of the binary number by its corresponding bit weighting factor, that is, bit 0 right pointing arrow 2 power 0 equals 1, bit 1 right pointing arrow 2 power 1 equals 2, and so on. Sum up all the products in step out to get the decimal number. Math operators. Arduino, like any other programming language, contains mathematical operators to code mathematical equations. Some of them are explained below. ABS of x. This operation calculates the absolute value of x and is applicable if x equals integer and long data types. FABS of x. This operation calculates the absolute value of x and is applicable if x equals float data type. Min of x, y, and max of x, y. This operation calculates the minimum and maximum of two arguments x and y. Pow of x, y. This operation calculates x to the power y. Sq of x. This operation calculates the square of x. Trigonometric functions. This operations calculates the sin of x, cos of x, and x has to be in radians, random of max. This operation generates a random number between 0 and max. Random of minimum, max. This operation generates a random number between min and max numbers given. Activity. Write a program to display minimum of the absolute values of 40 and minus 30. Write a program to find the value of sin of x plus cos of x square at x equals 1.5 radians. Solution. The code and the output for finding the absolute value is as follows. The answer is minus 40. Solution. The code and the output for the trigonometric equation is as follows. The answer is 1. A few programming essentials. Delay functions provides a delay in milliseconds. Delay microseconds function provides a delay in microseconds. MILLIS function gives the time exhausted in milliseconds, since the Arduino board began running the current program. Micros function gives the time exhausted in microseconds, since the Arduino board began running the current program. A few programming essentials. Delay functions provides a delay in milliseconds. Delay microseconds function provides a delay in microseconds. MILLIS function gives the time exhausted in milliseconds, since the Arduino board began running the current program. Micros function gives the time exhausted in microseconds, since the Arduino board began running the current program. Here in this example we will see how to use MILLIS function, which performs the same way as delay function. Example. Blink an LED with 1000 millisecond pause. To do this, as shown in the program, we need two more variables to keep track if the required time has passed. We have stored the current time in current MILLIS variable, but we also need to know, when did the timing period start, and how long is the period. So the interval and previous MILLIS is declared. The interval tells us the time delay and previous MILLIS will store the last time the event has occurred. Here, the first if checks if the 1000 milliseconds has passed. If 1000 milliseconds has passed, then the LED blink and again comes to same state. In case of using delay, the function is straightforward as we performed in the previous examples. We make the LED high, we delay 1000 milliseconds, and we make the LED low. This is how the loop executes. So, here is the difference between the two functions and using MILLIS instead of delay. This way it won't halt the program for any particular interval. Thank you.